Okay, for this last sample problem, instead of giving you a visual, we're actually going to give you the equation of a function. But you can see in the directions we say to use your graphing calculator to determine and classify its extrema values. Now, at this point, you don't have a mathematical way to test this or to figure out what these points are. So I'm going to walk you through part A to show you how to do the calculator portion. And then I'm going to let you work on part B to see if you can kind of figure out where to go from there. So the first thing I want you to do is I just want you to take part A, 5x cubed minus 10x squared minus 20x plus 7, and graph it on your calculator. Now, at this point in the course, before you even graph this, you should have some sense of what this graph is going to look like. And it'll give you an idea of the end behavior and various things like that. And so if we go over to our calculator, this is the view I get of my particular graph. Now, not a real good view because we can't see the whole thing, but I do have a basic idea. I know it's a cube, and I know on the cubic with a positive coefficient and an odd degree that as x goes to positive infinity, so does the f of x, and as x goes to negative infinity, so does the f of x. And so we know that this is going down to infinity, it's going up to positive infinity. So somewhere up here it's got a little peak, and somewhere down here it's got a little low. And so we have a relative minimum and relative maximum in this particular process. And I can kind of gauge that my minimum, my maximum is going to be somewhere between, I don't know, let's say -2 and possibly -1, somewhere between 2 and 0, -2 and 0 on that interval. And so that kind of gives us a little guidance as to where that maximum could be. And then we can also see here that this one's probably going to be somewhere between, roughly 0 and 3. So our minimum down here is going to be somewhere between those two. Now, a couple things that you could do is you can actually physically drag, if you will, by putting the pointer on the graph, and you can actually move that graph up so that you can see that maximum. Of course, we could take that and move it all the way down until we can see that minimum, and you can see that thing's way down there. You could also zoom out if you like to see the full picture. Now when you do that, what's going to happen is you're probably going to make it end up being really, really small. So zooming out can sometimes be complex. Now what we want to do here is we want to identify this maximum point right there, or in this case this relative maximum point. So I'm going to use the little menu function on my calculator. So if I go menu and then I go to number 6, I go to analyze graph, and I can see I have a maximum. Now with this maximum, what it's asking is it wants a range or an interval to find the maximum. So if I just move my little hand with the dotted line to the left of that, I'm going to actually create a little range. And so I'm just going to click on it, and then I'm going to move that over here, and I'm going to click on it again. And you can simply see that my maximum is going to be -0.667 and 14.4. So I'm going to go back and I'm going to write that in there. And so I'm going to say that my relative max is going to be -0.667 and then 14.4. So you can see there that we have a simple way to get that max. Now, let me drag my graph all the way down so I can get a visual of my minimum. I can do the same thing with my minimum. I can hit menu and then number 6, analyze graph, and then, hit minimum this time. And this time I just want my range or my interval to pick up that point where that minimum is. I don't really care to go any further than that. And I can see that my relative minimum there is 2, -33. So if I say relative minimum, I can say 2, -33. Now, we can also clearly see that there are no absolutes. So there are no absolute minimum or maximum, it has no bound. Okay, and so there's no bound as you go to positive infinity, there's no bound as x goes to negative infinity, and so there are no absolute minimums and maximums. Now you may see some textbooks or some questions ask you what's the max, and they would ask it to you in two different parts possibly, like they'll say what is the f, and then what is the value of f at a certain x, and so they could ask it to you a number of different ways. And so just be aware that especially in Math Excel, there may be some variance to the way they ask the question. But as far as I'm concerned, on a unit test, if I ask you a minimum or maximum, you're defining it as a point at which the graph could be drawn tangent, horizontally, or vertically. And so I would want it to be in the form of an ordered pair. So why don't you go ahead and work part B on your own using your graphing calculator. Use those minimum and maximum functions, and then you can come back and see the final answer. Okay, so hopefully you were able to use your calculator effectively. Again, we have a cubic function here that has an has a positive leading coefficient, which means that its end behavior is going to positive infinity and negative infinity on either side, thus taking away any opportunity for absolute minimums or maximums. And so then you would need to use your calculator effectively to find those little peaks that are within the middle of the graph. And these are the following answers. Alright, so that's a good example on how to use your graphing calculator for minimums and maximums.